Hello, everybody. I am Charlene Schwartzman, and I'm a high school math teacher. But today, I've got something up my sleeve. I have an idea for elementary school teachers when you guys are trying to teach fractions, and I know that's a tough concept to get across to kids. So I have this idea that we can do two things. I did something with the third graders and something with the fourth graders that I thought was super fun, and it was really neat activities where they get to use their hands, they get to color, they get to create things, and concepts like infinity come up, and cool number patterns where you're multiplying by fractions and you're dividing things up into fourths and things are getting bigger and smaller. So you can really have a really neat conversation with your kids if you give it some time, because I think one of the things is instead of just tossing things out at kids, to give them a reference or a place to start that's kind of cool and fun, you can really take them places and start asking some intense questions that you'd be surprised at what they can answer. So I look forward to showing you guys what I have up my sleeve. Let's go.
Come on, vámonos. Everybody, let's go.
And this was one of the activities that I did that I thought was so fruitful, and the kinds of questions and conversations that came out of it were really cool and really fun, and I think it really will create a nice foundation for how fractions work. So it's through Sierpinski triangle, and the first thing is I have this whole worksheet that you got, here, where you have stages, stage 1, 2, 3, 4, 5, and it goes on forever actually. And we talk about the number of shaded triangles, the number of unshaded, the length of one side, and the area of like one unshaded triangle. So what's really cool is within this realm, really cool number patterns come to life. And I would like to show you how they come to life. And I want to take them piece by piece because each one is deserving of its own platform. So to start off with, you'll see that these are what we call iterations. So this was stage 1. I'm going to kind of go opposite when I show you how this is shaded in. I'm going to do unshaded and then just kind of do opposite so it doesn't take up too much space as far as trying to color things in. It's going to just change things around a little bit. But I would love to show you where these things come from. And furthermore, if you want to take things up a notch, you can actually do a 3D lesson. You can actually build Sierpinski's triangle in 3D, which I have done, and it's really cool. So I might actually show you, because it comes from a bunch of tetrahedrons, that I can show you how to build and how to create actually from circles, which is kind of cool. So this is Sierpinski's triangle. And if you look over here, you will see what's really cool is that this is called the first stage, second stage, third stage, fourth stage, and fifth stage of Sierpinski's triangle and fractals. And what's happening in each stage is we are finding the midpoints of the sides and creating triangles. And then you'll notice that you're creating smaller and smaller triangles. And as you go on, you can see that you can start making like infinitely many. So the first thing I want to do is, and you can also do with your kids, is show you how this actually got, how these were actually sketched in. So this is stage 1, and stage 1 is like this guy. I'm going to leave it blank because it's a lot easier to shade. But this is typically what we would call stage 1. It would just be all by his lonesome, just hanging out here, not doing anything. So when I go into stage 2, however, I'm basically going to say to myself, let's go find your midpoints, which I'm going to do. Okay. You can have the kids estimate where they are. Let them use rulers so they can be real precise with it. I am not, because it's hard to do. I have a free hand here. So I'm going to go here. Look how crooked that is. So I have this. So this is what I have for my first stage. I'm going to come off of here. And now what I'm going to do is I'm going to go take this to my third stage, stage 3, because this is stage 2. And what's cool is you're seeing that I actually just took this guy right here and I created a really pretty triangle. And you'll notice all 4 of these triangles are the same size. Everything is going to come into play later. So when you want to start stage 3, you actually have to start with stage 2. That's why they call them iterations. You need to know, I don't like where I put that point there. You need to know what happened prior to in order for you to kind of move on. So I'm going to say my midpoint's right about there and here. So I'm going to play connect the dots, la 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 la. So I'm just going to go ahead and sketch this in. And now with a new color, I'm going to go over here in my orange. And I'm going to go find those midpoints. And I think spending the day with the kids, or like letting the kids actually create these, is really cool because they can see how iterations work, how they're doing the same thing over and over again, but everything keeps getting smaller. And then we can find out just how much smaller they're actually becoming as time goes on, which is kind of cool. So that's the one thing that I do like about this, is that it feels like you can see when if you use colors and stuff, it actually starts to look a little artistic and they kind of get into it. Okay, so that's stage 3, and you can see that stage 3 here matches the stage 3 up there. In fact, mine actually looks prettier as far as I'm concerned. So now I'm going to show you, let's go to stage 4. Now, if you want to fast forward, I don't blame you. So we'll go to stage 4. So now I'm going to go here, and I'm going to come in here, and I'm going to go ahead and create my stage 4. Now, the important thing is for the kids to recognize is that the blank spaces, or the blank triangles that don't have any color in them, that's where they're creating their new triangles. When I did this with a couple of 4th grade classes, that was something they had a hard time with. So it's important to say you have to go look inside the triangles that don't have color on them and go ahead and fill them in. So I think actually, as I'm saying this out loud, it's probably smart to let them use different colors so they can see the different iterations and stages as they're going through and doing it, because it actually really helps with the visual. So if you let them use like colored pencils or something like that, it'd be pretty cool. I like to let them use like giant sized triangles, like really big triangles, triangles that almost take up the whole page. So that way they can really get in there and go to extra stages, because this is only stage 4. So I would want them to go on to like stage 5 and just be like, okay, can you do stage 5? Can you do stage 6? And because I made the triangles so big, the kids were able to do, I think I had a group of kids that went up to like stage 7 or 8. And so, and you can actually see up here that stage 5 gets you there. So I think it's really important to let them to see that, and to see that as time goes on, everything's getting smaller and smaller, i.e. the iterations. So I would start with that. Now, after you've done that day of that, I think it's kind of cool now if you go back. And now the chart is going to come into play, and it's all going to be based on the stages that the kids created. So they get to be the ones to put all of this together. So in stage 1, which is this guy right here, I'm asking for the number of shaded triangles. There aren't any. Unshaded, there's 1. And let's say we made the length of this side 1, because I believe up here, if we begin the original triangle, both the area and the perimeter are 1. So the area of this triangle here is 1. So based on that, we're going to see what happens to the other triangles as we move along. So we know the length of one side of this original triangle is 1, and the area of it is also 1. Now we go into stage 2. Now you can have the kids go look at stage 2, and then you can say the number of shaded triangles, and they're going to be like, okay, there's 1, because they see 1 of them. The number of unshaded triangles, they're seeing that there's 3 of them. The length of one side of the shaded triangle, well, if this whole thing is 1, there's a really good chance your kids are going to tell you that this distance here is a half. Okay, so you know you can put your 1/2 in here. And then the area of one unshaded triangle in relation to the entire triangle. So if you take one of your unshaded triangles, right, there are how many of those of the same size, or how many of those triangles take up the big guy? Your kids should be able to come up with 4. So if I ask for the area of one of those, they should be able to tell you that it's 1/4. Okay. Now, as we get along here, the stages 3 and 4, it's going to start to get a little interesting, but it's totally worth it. So in stage 3, the number of shaded triangles, there are 4 of those. Okay. And the number of unshaded triangles is, I'm looking there are 9 of them. Okay. And the length of one side now, well, it's been broken down into fourths. So 1 has been broken down into fourths. Right? So therefore, each one of these segments represents 1/4. Okay, so there's 1/4 right there. And then the area of one unshaded triangle in relation to the original guy. So the thing that your kids are going to probably make mistakes on is they're going to add up all the triangles and assume that this big pink guy right over here is going to make it 13. Because if you add all of these triangles up, you have 4 here, you have 4 here, you have 4 here, so that's 12. So they're going to tell you it's 13. But I'm telling you what, my advice is I would cut one of these triangles out and have those handy dandy, so that way they can recognize that if you partition this purple triangle, you can actually turn it into 4 triangles. So that way the kids can actually talk about congruency, and there's congruency. So the thing that I love about Sierpinski is that now you're talking about congruent triangles where they're the same size and shape. Clearly the purple triangle is so much bigger than the orange one and the white one. So now you can basically say you need 4 of those to fit in. So now if they fit it all in there, they know that there are 16 small triangles, and that means that one of these guys right here right? This guy right here represents 1/16 of that. So we know that that's 1/16. Okay, so now, again, I would go over here into my stage 4, and again, we're going to go and fill everything out. The number of unshaded triangles, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 of those. Am I right? 4, 4, 4. Yep, there's 13 of those. And then you talk about the number of unshaded triangles. You have 3, 6, 9, 12, 15, 18, 21, 24, 27. So there's 27 of those. And again, give them time to count all of this out. So now when they look at the length of this side of the triangle, the cool thing is now you want them to look at that and say, well, how many pieces is this broken down into? This one has been broken down into, and they should all recognize that it's now 8 pieces. So each one of these represents 1/8. So if they go along, they can say that the length of each side of this new triangle here is going to be 1/8. Now, what's interesting is now we have to figure out if we take the area of one of those unshaded triangles, right? How many does this guy right here represent in the entire figure? So the cool thing is that you guys can now recognize is that there are 3 different sized triangles in this diagram. There are 3 of them. Now there's one way that you can look at this, right? You can go ahead and you can say, okay, we can take the orange triangle, and like we did over here, we can break it down into 4 triangles. So in this big block right here, have the kids count out how many triangles, small triangles there are, and they're going to tell you that there's 16 small. Okay? Now, have them do, so if there's 16 small here, they should be able to tell you that there are 16 small in this one, 16 small triangles in this one, and then 16 small in the middle guy. So they should be able to come up with 64 of them. So there's 64 total small. Okay? Now this is going to take them time, which is why I think this is a project or like an activity that they should just have time to be able to focus on, which I'm kind of digging. So for them, hopefully they'll tell you that one of the small triangles, the teeny tiny one, represents 1/64. Okay? At this time, I would recommend that you ask them to see if they could predict what the numbers would be, because if you look across here, all of these little number sequences are telling you a story. They're telling you what they are. Okay? So they're telling you what they are. And based on that, so this has a difference of 3. This has a difference of 9. That's pretty interesting. That one's a little tough. But the 1, 3, 9, 27, the kids should recognize it's being multiplied by 3. So therefore, they should be able to come up with 81. Again, if you give them the time for that. On this one over here, if it's 1/2, 1/4, 1/8, and it goes 2, 4, 8, the kids, you would hope, like you're going to say, oh, they should recognize the next one is going to be a 16th, because you're multiplying your denominator by 2, i.e. you're multiplying each one of these fractions by 1/2. So now you can get into multiplying by fractions, which is pretty cool. And then finally, for the last one, you have 1, 1/4, 1/16, 1/64, and you can have the kids come up with that. They get so excited. They're like, wait a minute, you're multiplying the denominator by 4, and it's like you're multiplying the whole thing by 1/4, right? So you're going to multiply 64 by 4, and if I said to you, what's 64 times 4? It's going to say, I'm going to say it's 256. So this is 1 over 256. So from this, what's pretty cool is you're taking number patterns, and these number patterns came from this activity. So within this activity, you have, if you add up 1/4, 1/4, 1/4, 1/4, you can say it's 1. If you add up 8/8, it's equal to 1. If you add up 2 halves, it equals 1. So you can start getting into those kinds of fractions. You can get into multiplying by fractions. And it's just so cool how these number sequences keep coming up. So you can say, can they predict 6? And they're going to want to. So if you look over here, the difference here is 3, right? So this is, they added 3, and here you added 9. So if you look below, I think your instincts would tell you, be like, it's 27. So if you add 13 to 27, I'm feeling 40. So the kids can be like, okay, so if you added 27, by looking down here, they can be like, oh, you're adding 81 for stage 6, and that could be like 121. Let them come up with the number patterns, and it's so cool because it feels so empowering, and again, it comes out from this really cool activity. Now, what you could also do is you can look at this column, this row, and you can say these numbers keep getting bigger and bigger and bigger. are they going to? And they should be able to say infinity. They're gonna like shout that word out, infinity, which is kind of neat. And then you can look at these numbers and say to them, what's happening to those numbers? And they should be able to tell you this is, they keep getting smaller and smaller and smaller. And if they keep getting smaller and smaller and smaller, what number are they approaching? And they're going to be able to tell you. Some of them will be like 0. So you can talk about these ideas of, things going on forever. And you can even say, will they ever get to 0? And what's really neat is you can take them there. And I strongly, strongly suggest that you can, because this is such an awesome activity that can get them there. So it's just about building triangles, and it all starts off with a triangle, which is why I think it's so cool. So I want to kind of go back to what I was saying to you earlier, because I feel like I kind of rushed through it and I'm not a fan. And, I want to get into, come on, this thing lights up and then it doesn't want to work. And what I like is that there are really cool things that you can get out of this. And I think I'm going to take my time with each one and kind of go through what they have to offer. So I think getting your kids, to create these really cool iterations of Sierpinski's triangle is so neat, number one. And number two, if you can get them to fill out the first, 4 stages, that's pretty awesome, because from that they can start to see number patterns. If you want them to go to 5, all right. That's gonna, it's gonna take them time to piece stuff together, which I kind of like though, because they're the ones putting stuff together. And again, it gets a little tricky when it comes to the area part, because if you go back to what I said earlier, when they count up how many triangles there are in the figure, for example, in stage 3, they're going to tell you that there's 13 triangles, which there are, except they're not 13 congruent triangles. There's 12 congruent triangles, and then this pretty purple one here. So my advice, as I said earlier, would be to have a cutout of one of the small triangles so they can actually put them in here and go ahead and do that. So you can talk about congruency, like I said before. But what you could also get into is you can get into transformations. Like you can talk about symmetry, you can talk about rotations. Like if like how did this guy get over here? Was it rotated? Did it reflect across a line? Like what did it do? So you can have a lot of fun with these triangles by doing that. The other thing is you can also talk about what fraction the purple guy takes up of the entire area, and there's a good chance they're going to be like, well, that's 1/4, but a small one takes up a 16th, right? So one of these small guys takes up a 16th. If you go over here to stage 4, they should still be able to look at this big, beautiful purple triangle and say it takes up 1/4 of the total area, which is kind of neat. And then you can have them go over to the orange guy and say, well, how many of those actually take up the big space? So they can actually look at this triangle here in orange that I have highlighted here, and then recognize that this guy is his same size, this guy is the same size, this guy is the same size. So there's 4 in this space, kind of like what we did over here, because this 4 of these fit into this space, so 4 of these is what I'm talking about would fit. So they can actually say like there's 16 medium size that would fit in. So it would be a 16th of so the orange represents a 16th of the total area. The purple represents 1/4 of the total area. And then the green ones, again, it might be smart to cut out one of these small triangles so they can actually see how many would fit in here and then actually how many would fit in here. So it would be kind of cool to let them just mess around with it, rotate stuff, draw things in, so they can actually feel what it's doing. So you can really get into similarity and congruency, and you can say, how much bigger is the orange triangle to the small triangle? How much bigger is the purple triangle to the orange triangle to the green triangle? So now you're talking similarity. It's so cool. And think about it. This is one activity with all this cool stuff that you can totally get into. So, and you can say, what fraction is this to this? What fraction is the green to the purple? So you can really get into some really cool mathematics here with the kids. And it's really honing in on fractions and the visuals right in front of them as well, which I think is kind of neat. Now, what I also wanted to say is that the green, if I come back over here, and if you remember, I said that the length of this side was 1. You can start it off as 2. You can start it off as 5. You can start it as anything as you want. So if I make this whole length 5, right, and I'm breaking it down into fourths, each piece represents a quarter of 5, then you can find out what a quarter of 5 is, so you know that. So if you go over here, if this is 2, then this is clearly 1 and 1. So if you go over here and you make the length of your side 5, they know this from here to here. Wait a minute, why am I making it 5? If this is 2, right, then this whole thing is 1 and this whole thing is 1. So that means this is a half, this is a half, and half, and so forth. So you can really have them break it down into, well, how many halves do you need to make 2? And they can say you need 4 halves to make 2. And then you can even go so far as to say, I hate how sloppy that looks. You can even go so far as to say, how many halves do you need to equal 1? So you can go over, whoops, there we go. How many halves do you need to equal 1? So if this is 1, they should say, oh, you need 2 halves. And then again, if you go over here, right, and now you have 8 pieces that need to be broken up. There's 8 pieces for this like length of 2. So you can get into, how much does each one take up then? How, what length does each one take up if you're breaking it down this way? And they should recognize eventually it's a quarter piece. So it's so cool how you can get into the fractions on this lesson. I love it because you can really take the kids places with this. And again, you get into the concept of infinity, you get the concept of 0. And, if you look at this guy right over here, you can go for it and just say, you're doing 2 times 2, and this is times 2 and times 2. And, and what you can do is you can really start getting into like, I know it sounds crazy. You can even get into exponents. Like, what if I wanted to go to 1/2 to an eighth? What would I have to multiply by? And, because that 4 is equal to 2 times 2. And then, well, 8 is 2 times 2 times 2. And then, 16, maybe they can see it as 2 times 2 times 2. So showing different ways that you can represent stuff, and then you can actually go there. Yes, you can. You can say that 2 times 2 is called 2 squared. 2 times 2 times 2 you can say is called 2 cubed. You can say 2 times 2 times 2 times 2 is 2 to the 4th. And when you have them, what you can do, again, this is why it's so cool, when you're looking at these exponents, and by the way, this would be 2 to the 1st, okay? When you're looking at these exponents, have them look at the stages that they're actually in, and then let them kind of take it from there. So if this is, if this is 2 squared, they're in stage 3. If it's 2 cubed, they're in stage 4. So let them figure out that it's actually 1 less, and see if any of them can actually come up with the nth term for that. You might be surprised. You might be surprised. And then the same thing here. This is 4 times 4 and 16 times 4. So you're multiplying by 4 every time. And by the way, these 3 here are called geometric series or geometric sequences. Okay, these are geometric sequences. And what that means is geometric sequences means to get from one number to the other, you're multiplying by the same exact number every time, which is kind of cool. So this we're always multiplying by a 4th. This we're always multiplying by a half. This we're always multiplying by 3. So these are called geometric sequences when you're multiplying by the same thing every time, which is equal to, and this is where I take my kids in my classes to what's called exponential functions, because exponential functions, you're multiplying by the same factor every time. And that's where this all ties into. So anybody who's at, even the 7th grade level or even 5th, anything, 3rd and 4th and above, you can decide how far you want to take your kids. But for me, I'm just trying to show you the places that you can actually take them and just let it run. And if you give them the time to drink it in and ask the right questions, I do believe that they might actually respond, and it's kind of cool. So I just think it's so cool.